All right, for this bell work, we got old-fashioned inequality just like we saw from last time. So we're going to solve this inequality, okay? But we solve it just like we would an equation, just with one exception. If we ever multiply or divide both sides by a negative, then we know to flip the inequality. In this case, we got the -9 that needs some distribution. So that's the first thing we would look for if we're ever looking at any type of equation or inequality. It's -9 times 4x, which is -36x's. And then -9 times 3, which would be -27. Nothing else really changed on that, so it still stays the same. But now that we've done all the distribution, we look for any combining of like terms, which we have. -27 minus 25, which is -52. And then we also have the 18 plus 2, which is 20. So now I got -36x, which dropped. And this is less than, minus 52 is less than 20. Next, I want to isolate the x's with some principles of equality. So in this case, I'll add 52 to both sides. To zero that out, I'll drop my -36x again, which is still less than 20 plus 52, 72. So another, that principle of equality we just used, or combining like terms or distribution, will not affect the inequality. But now that we got that, we're just going to divide both sides by -36 to make the coefficient of x a phantom 1. So I got x, 72 divided by -36 is -2. But in this case, we did divide both sides by a negative, which will flip this inequality. So now x is greater than -2. Now, I didn't ask for it on the bell work, but I'm going to graph this just as a quick reminder. We want -2 in the middle. So -1 would be to the right and -3 to the left. This would be an open circle at -2, and then it's eating the x. So this line would go to the right. There's the objective. I can solve equations with absolute values. Take 30 seconds and copy that down, please. So a quick reminder about absolute values. An absolute value is the distance from 0. So we can see it in a graph like this. And the absolute value symbols look like this, okay? Now those aren't ones, they're just straight lines like this. And so if we saw something like even like this one right here, that would read the absolute value of -5. Okay, so we can use these symbols to kind of write this out shorthand, because I don't know anyone that would want to write this out in words right here, but with symbols we can do it pretty quick. But what is an absolute value asking? It's really asking how far is a value from 0. So if we saw something like this, the absolute value of 3, it's really asking the question, how far is 3 from 0? Now that means it's a distance, and we never actually communicate distances with negatives. So 3 is still 3 away from 0, so that's why this is equal to 3. That's why this one right here, the absolute value of 5 is still equal to 5, because 5 is 5 away from 0. How far away is -5 from 0? It's 5. So it's the same distance from 0, just in a different direction. You could say it's like this one is 5 units west, this one's 5 units east. It doesn't really matter, it's still 5 units, okay? So we never actually communicate with distances like that, with negatives. It'd be like saying, well, I live -40 miles north of here, instead of saying directly I live 40 miles south, okay? Because we don't communicate with negatives when we talk about distances, because if you do, then I hope you have a good career in politics someday, okay? So, now change this around though, because like it says, we're gonna be finding absolute values of x. That's how this reads. This is the absolute value of x. And then we have to ask a different question when we see that. So it's what values of x will make the statement true, okay? So if I said, let's look at the absolute value of x, let's say that it equaled, I don't know, 7, okay? So the question here, just from this absolute value, is what values of x will make this true? Okay, now, another way to ask this this question is, what values are 7 away from 0? Well, if we ask it like that, I think it works out a little bit better because we know that 7 is 7 away from 0, but just like we see on this graph up here, there's another value that's 7 away from 0, just in the other direction, and that would be -7. So we end up having two answers, which is a little different. In the last unit, we saw that it's possible to have no answers. It's possible to have infinite solutions. It is possible to have one solution, but now we're saying that in certain scenarios, it is possible to have two solutions like this. All right, now, I was saying that absolute values are always positive. So if I said, look at this absolute value of x, let's compare it with -8, okay? So this is asking what value is -8 distance away from 0? Now, some people would say, especially when we're just learning this stuff, they'd say, well, -8 is -8 from 0. That's true. It's just that, remember, this is a distance, and we don't talk about these in terms of distances. So this one, we actually end up saying there's just no solutions. Okay, so if you ever end up with an absolute value, and there could be more in there in the absolute value than this. If you ever see that an absolute value equals a negative, that cannot happen. Because absolute values, distances, we never refer to distances as negatives. So be careful on these, because some students look at these and they're like, it's a negative, then a positive. So this one should be a positive, then a negative, because it's opposites. It's not opposites. Okay, it's just that it's always, I just can't emphasize that enough right there with that bold print. It's just always going to be a positive value because, again, it is a distance. So that's a nice quick introduction. This one, again, that's the absolute value of 34, which really is asking how far is 34 from 0. And hopefully we know by now, hopefully, that the answer to that would be 34. It's just 34 away from 0. Or this one, we can look at big numbers as well. It's not really going to matter, but this asks the same question: how far is -1,542 from 0? Well, it's to the left of 0, but it's still a positive value. It is exactly 1,542 units from 0. So again, that comes out as positives. And as of right now, we don't have the calculators here that you could put absolute values into the calculator. There are some that do, just we don't have any here in class. Now this one works a little bit different, okay? So let's look at this one a little closely. Now we got that negative out in the front. This ends up being an order of operations type problem, which if the calculator had an absolute value button, it would be great, but it doesn't. So this negative out here, sometimes it benefits students to see that as a -1, like this. That's being multiplied by that absolute value. Since it's being multiplied by the absolute value, we have to evaluate the absolute value first because absolute values are classified with parentheses. So we have to solve that first, okay? So again, our first question here would be, how far is -2,365 from 0? And last time I checked, it was, not that I've ever actually checked, but it should be 2,365 units away from 0. Since I've evaluated that absolute value, notice the parentheses change. And now I'm ready to solve this because we still have that -1 being multiplied by that set of parentheses. Okay, now I know anything times 1 is itself. So the answer here is going to be 2,365. It's just anything, well, it's a positive and a negative. They're opposite signs. So I know the answer is going to be a negative. Negative 2,365. Now, a lot of students look at this and they say, hey, Mr. Sal, we can't have any negatives as our answers. Well, that's true, not from the inside, okay, because we did evaluate that absolute value of -2,365. That was positive, but since it was being multiplied by a negative, that's what made this negative, not from the inside, okay? And there is a big difference there. So we use principles of equality pretty much the same way. And we're not looking at inequalities right now in this particular section, although the last one we did. But when we look at addition and subtraction here, remember that is to make zeros. And the question should be asked, well, why would we want to make zeros? It's because when we do make zeros, we want those to be phantom zeros. Essentially, we want to make them go away first. So we got multiplication and division. These two principles of equality are what we use to make ones. Now, in the past, we use these two principles of equality to make ones when it's the coefficient, most of the time. But we've seen other examples, like here on the left, where it's like 3 equals 4 plus x over 5, and then we had to multiply both sides by 5. This was to make a phantom 1 here, so that we can get rid of that fraction. And then we would have just ended up with 4 plus x equals, what, 15? So it's not always just to make the coefficient, although most of the time we use these two principles of equality to force the coefficient to be a 1, a phantom 1, which we actually saw in the bell work. All right, so solving inequalities. Remember when we were solving inequalities, just like we would with equalities, right? You got distribution, combining like terms, principles of equality, divided by the coefficient. It's just now we're looking at equalities again with these absolute values. All right, so absolute value equations. The first thing you'll ever need to do on these is you got to actually force the absolute value to be by itself. You can't have anything added or subtracted on the outside of it. Okay, so if you have an absolute value, and there could be lots of stuff in there. It could be fractions, there could be addition, subtraction, could be x's, could be numbers, who knows. But you may have to operate within. It's possible that you could have stuff on the outside, like a -4 plus, and then a plus, I don't know, 15 out here, something like this. You have to use principles of equality to zero out any addition or subtraction, and you have to use principles of equality to force any multiplication or even division to be phantom 1s like this. So you'd have to get rid of this garbage first, okay? And then once we get to that point, we can show you what we do from there. But eventually, just like we saw a few slides back, we end up having two answers. And so once we have solved for the absolute value, once you just get an absolute value equals some number, then we start splitting the inequality, or the absolute value, into two separate equations. We'll talk about that more here in a second. All right, so here's our first equation that we get to work with. B minus 6 equals 6, okay? Now it's an absolute value, okay? So just think about this above, okay? So if I could get this absolute value, if I could just get B minus 6 to be 6, then I know that it would equal 6, right? And that would give us a true statement. If I could just get B minus 6 to equal this 6. On the other hand, if I could get B minus 6 to equal -6, because it also is 6 away from 0, then I would also have a true statement, okay? So what we end up doing from this is we take this B minus 6, that's from the inside, B minus 6. If I could get it to equal this 6 here, then I get a true statement in the end. Now that's one equation that I can solve. And you could solve that right now, but I want to point this out, that if I could get also B minus 6 on the inside, if I could force it to equal -6, then I still get a true statement, right? And this -6 would be this one on the inside. Okay, so if you can get the inside to be whatever you want it to be, you can force these statements to be equal. Okay, so let's look at this statement on the left. B minus 6 equals 6. You add 6 to zero that out on both sides, just like a regular equation. Zeros that out. Drop your B. B equals 12. Okay, and let's check, see if this works. 12 minus 6 is 6. See, remember that was kind of what we're aiming for here. 6, the absolute value of 6 is 6, so that checks off. And I know that 12 would give me a true statement if I replace B with 12. On the other hand, B minus 6 equals -6. I'm going to add 6 to both sides here to zero out that -6, and I drop my B. B equals -6 plus 6 is 0. All right, so you're saying if I replace B with 0, it'd be true? Let's find out. 0 minus 6 is -6. Remember, that was kind of what we were aiming for there. And the absolute value of -6 is actually 6. So 0 also checks off, which means in the end, we end up with two answers. I'm going to list these in order from least to greatest because on the homework, it will want them listed from least to greatest. The smallest one is 0, and then we got the 12. Okay, least to greatest. We already checked both to make sure that they were actual solutions to this equation. But you should pretty much expect all of your problems to have two solutions from these absolute values. If you ever see an absolute value equation, expect there to be two solutions like we see here. Okay, so a lot of students ask, well, how does this, we can't make this equal to -6. Remember, this -6 was from the inside of the absolute value, it is not this 6 right here, it's very different. All right, so let's try this one, okay? So once again, I'm gonna point this out. If I can get the absolute value of -9 plus 2n, if I could just make it 15, then I know that absolute value of 15 would still be 15, okay? So that gives me one equation. That's the -9 plus 2n. If I can get it to be equal to 15, if I could change it into a 15 like I've done here, I'll get a true statement, okay? But if I can just make that absolute value, the -9 plus 2n, if I can just make it -15, then I will still get a true statement, okay? So I end up with these two equations right here, -9 plus 2n. If I could just change it into a -15, like this, I will end up with a true statement like this, okay? So that gives me the two equations that I need to solve. And so let's go and start solving. I'll start on the left with the red right there. So that's let's add 9 to both sides. That's going to zero that out. I'll drop my 2n, which equals 15 plus 9 is 24. And then I'll have to divide both sides by 2. So n equals 12. Now let's just check to make sure that'll work. So that'd be 2 times 12 is 24. -9 plus 24 is 15. Remember, that's what we were aiming for. The absolute value of 15 is 15. That's true. Now, notice now 2 times 24 is this 24 as well. So we should see these values, 24 and then 15, and then the absolute value 15 be 15. Okay, we should see these values come back to us when we start checking our work. All right? And it's going to happen the same way over here in purple as well. So first thing I'd want to do there is to zero out that -9, so add 9. But if I do it to one side, I got to do it the other side. Principles of equality. I'll drop my 2n. Now equals -15 plus 9. That'd be -6. And then divide both sides by 2. That will give me n. That's going to phantom 1n equals -3. Okay, so let's check. Let's see if that works. Okay, so 2 times -3, that's the n. That's -6. Remember, that's kind of what we were planning on. -9 plus -6 is -15 as well. That's also part of the plan. And the absolute value of -15 is 15. That checks off. So I'm going to list these from least to greatest because on the homework, once again, they will want the answers in order from least to greatest. So the smallest of the two is -3 and then 12. Okay, so that's how you'd have to list those in Canvas. There's a box for each of them, by the way. So you type in -3 in the first box and then 12 in the second box. Now, something else I think you should notice on this is the work for both equations is exactly the same. You add 9 to both sides and then you divide both sides by 2. It actually mirrors itself because it is the same expression that we're dealing with. It's just they equal something different for both. And so we end up with two different answers in the end. So this one, a little bit smaller, but the process is the same, right? If I can get that, the inside of that absolute value, if I can just get it, that -7x, if I could make it equal 84, this would be a true statement, okay? On the other hand, if I can get that -7x to equal -84, I would still get a true statement, okay? So these two are both one-steppers. They're going to take one principle of equality to solve, so I'm going to divide this left side by -7, but if I do it to one side, I got to do it the other side. This is going to give me x, it's a phantom 1x, equals 84 divided by -7 is -12. Same process over here. I'll divide the left side by -7 to make that a phantom 1x. But once again, if you do it to one side, you got to do the other side as well. Okay, so this is going to equal -84 divided by -7 is now +12. Well, will these work? Let's find out. So -7, let's start with green. -7 times -12 is 84 as we planned. And the absolute value of 84 is 84. That's true. What if I replace x with 12? Well, -7 times 12. Remember, we should expect this to be -84, which it is. And the absolute value of -84 is still 84. So we end up with two answers. These ones are already listed from least to greatest. So x would be equal, it would equal -12 and 12. Now, is it possible to have your absolute values on the right? Yeah, sure it is. Okay, so We can still operate with this though. Okay, and I'm just going to break it up from the right instead of the left. Okay, if I can get the inside, just the inside of that absolute value, 9 minus 8x. If I could get it, you could even put it over here. If I could make it equal 17. So again, this red 17 would be on the inside of the absolute value. If I could make that happen, I'll get a true statement. On the other hand, if I could get that 9 minus 8x, if I could make it equal negative 17 on the inside of the absolute value, I'll get a true statement as well. Okay, so once again, we see that the processes are the same. Like for this equation here on the left, I'd subtract 9 from both sides. But it also works over here. Remember, it's just mirroring itself. So subtract 9 there. So I'm going to do these simultaneously, although you don't necessarily have to. 17 minus 9 would be 8. This would equal, that's going to zero out, but I'll drop my negative 8x. And then here on the right, negative 17 minus 9 is negative 26, which equals this zeroed out, and then I drop my negative 8x. And then finally, we would divide both sides by negative 8. So I'm showing the division a little different, but it is still division. I get phantom 1, x equals 8 divided by negative 8 is negative 1. There's phantom 1x. Again, x equals negative 26 divided by negative 8 is positive 13 fourths. And you can let the fraction do that simplification for you. Let's go ahead and check though. So start with negative 1. 8 times negative 1 is negative 8. 9 minus negative 8 would be 17. Remember, that's kind of the point here. And the absolute value of 17 is 17, so that checks off. What about 13 fourths? Well, 8 times 13 fourths is going to be 26 fourths. So it's 9 minus 26 fourths. Let's see. Let me make sure I'm doing that right. 26. No, it'd be just 26. 9 minus 26. And the negative 26 here comes from the minus 26 right there. So 9 minus 26 would be negative 17. And the absolute value of negative 17 is actually 17. So that is true. So we end up with two answers again. Let's show what they are in order from least to greatest, starting with negative 1 and then 13 fourths. It is possible to have fractional answers, which I believe you will see on the assignment as well. All right, for this one, yeah, we got some more stuff on the outside of that absolute value. No problem. Again, we just want to zero out some of that stuff, which we will do. So first off, I see that I see the minus 7x. We'd have to zero that out first. So I'd start by just adding 7 to both sides here. And that will zero that out. 23 plus 7 is 30. I didn't really do anything with the fractional part there. So it's just going to stay the same. I'll drop it. And this equals 30. Okay, now again, just like we saw before, to get rid of a fraction like this where it's all over 4, just multiply both sides by 4. That will create a phantom 1 situation. But if you do it to one side, you got to do it to the other side. So now I'm left with 3x plus 6. And we didn't touch the numerator. But this is equal to 30 times 4, which is 120. Now that I've gotten this far, I'm ready now to break this up into the two equations. Because if I can get that 3x plus 6, if I can make it equal 120, then it'd be a true statement. If I can get that 3x plus 6 to equal negative 120, it'd still be true. So here we go. Let's go and solve these both. Subtract 6 from both sides. I'll do one at a time this time. So that's 0 out. I'll drop my 3x, which equals now 114. Divide both sides by 3 here. And x equals 38. And then on the equation on the right, so same process. Subtract 6 from both sides. Just we do get different answers here. Drop your 3x, which equals now negative 126. Divide both sides by 3. And x ends up being equal to negative 42. Okay, so again, the last thing we'd want to do on this, you should check with your calculator, but just to save us a little time today, x would equal first negative 42 and then 38. You'd have to put it in this order on the assignment. All right, negative 7 times the absolute value of 6x equals negative 63. Take a minute to try to solve this one, then we'll go over it, okay? 1 minute. is that we don't want this negative 7 being multiplied by the absolute value. So I'm going to make that a phantom 1. It's being multiplied, so it'll be phantom 1 with division. I'll divide that negative 7 by itself. Negative 7, if I do it to one side, I'll need to do it to the other side as well. Okay, so that becomes a phantom 1. I'm just left with my absolute value of 6x, but it now equals negative 63 divided by negative 7 is positive 9. Okay, so now that I got my positive 9, I'm going to break this up. I want the 6x. If I could just get it to equal 9, it'll be true. If I can get that 6x to equal negative 9, it will still be true. Okay, so divide both sides by 6. On this first equation, in purple, I get x equals, this would simplify to 3/2. And then on the right side, still divide both sides by 6. Just now, x equals a negative 3/2. Okay? So, once again, the last thing we want to do here is just list these in order from least to greatest. The first one would be the negative, and then the positive. All right, so once again, we got some stuff on the outside of that absolute value. We don't want that stuff, so we're going to have to zero out some of that stuff. Starting with the minus 7 right there. So, yeah, let's get rid of that garbage. So, add 7 to both sides. And we'll zero that out. And 21 plus 7 is going to be 28. Okay, nothing else really changed. We still got that 4 times the absolute value of 2x plus 8, which we did just drop, by the way. Is going to equal to 28. Now, you'll notice that this ends up being kind of like what we did in 2.7 with manipulating equations, okay? Because I'm solving right now for the absolute value. I don't really care what's on the inside. I just want it by itself. So I don't want the minus 7 with it. I don't want the times 4 with it. So now I'm going to get rid of that times 4 by dividing both sides by 4 to make that a phantom 1. So I'm just left with the absolute value of 2x plus 8 equals now, though, 7. All right, and now I'm ready, since I have solved for the absolute value, to split this up. So I'd say 2x plus 8 would have to, if I could make it 7, that'd be true. If I could make my 2x plus 8 equal to negative 7, that'd still be true, okay? And then would subtract 8 from both sides here to zero that out. Drop my 2x, which now equals a negative 1. Then divide both sides by 2. And I see x here is first negative 1/2. I'll do the same thing to the other equation. Subtract 8 from both sides. That'll zero that out. Drop my 2x, which now equals negative 15. Then divide both sides by 2 again. So x equals, in the end, negative 15/2. Don't worry about changing that to a decimal, okay? Now, it will want the answer in order from least to greatest. The more negative it is, the more smaller it is, or least value it is. So our first value that we need to list in Canvas would be negative 15/2, and then the negative 1/2. All right, so there's our objective. Again, I can solve equations with absolute values. And we know by now, hopefully, that most of these will have 2 solutions. 2 values that will make the original absolute value equation a true statement.